Hello, I am Professor Veena Shettigar. Today I am going to take the experiment to determine the frequency of AC mains using sonometer. So this is the circuit diagram of the experiment. As you can see, there is a AC source, then there is a ammeter, then there is a rheostat, and then the sonometer box, and we have to connect this according to the circuit diagram. Now this is the circuit diagram. As you can see, the sonometer is connected in series with the rheostat with a source which is AC source and a ammeter which is an AC milliammeter. And then as you can see, the sonometer, the wire has, there is a weight attached which is hanging freely from the table. So this is the arrangement of the apparatus. Now you can do the connections according to the circuit diagram. To arrange the apparatus first according to the circuit diagram, this is your AC power source, this is the rheostat, this is the sonometer box, then this is the millimeter. All are connected in series as shown by these wires. Now for the sonometer wire, you use a crocodile clip. This is your crocodile clip. Now you have been given two magnets. Now the north and the south, they attract each other. You have to adjust the magnets in such a way that it is perpendicular to the wire between the two knife edges. You keep it in the center between the two knife edges. Once you have done this adjustment, then and then only you will put the circuit on. That is, you will put the supply on and put the switch on. So as soon as you put on the switch, some current will flow in the circuit. If there is no current in the circuit, you adjust the rheostat such that the current is approximately 0.1 or 0.2 amperes. Once you have adjusted this current, throughout the experiment, the current will remain the same. Now, you attach a mass of 20 grams first, which is the hanger itself. Now you have to find the resonating length of the wire, that is the distance between the two knife edges. For that purpose, you have to adjust the bridges, knife edges in such a way that maximum amplitude of the wire is in the center. So by adjusting, we will now adjust and we will see how to get the maximum amplitude at the center. Can you see this? The maximum amplitude, the wire is vibrating with maximum amplitude at the center, and there are nodes formed at the two knife edges. These are the nodes and maximum amplitude is at the center. At this point, you will take a scale and measure the distance between two knife edges. That is your resonating length, which you can tabulate in the observation table as L1. Now for the next reading, you have to just change the knife edges slightly and tabulate the second reading for the same mass. In a similar way, you will go on changing the masses by taking 20 gram, 40 gram, 60, 80 and 100 and find out the respective resonating length. And then you can do the further calculation. So you can see in the observation table, there is a column for mass suspended, there are columns for resonating length, there are 3 columns, then mean L and L square, and one more column is for M by L square. After that, you can do the calculations L square, M by L square. You can be using a simple calculator to do these calculations. Then substitute this in the formula for frequency, which is given here. N is equal to 1 by 2L square root of mg by small m. Now this small m is linear density of the wire, which is given to you, which is 3.84 into 10 raised to minus 3 gram per centimeter. After this, plot a graph of
M versus L square, you will get a straight line graph as shown, and then again you can calculate the frequency, which is using the same formula, but for M by L square you will write down the slope. The results which are expected is frequency of AC mains should be approximately 50 Hertz.